Hey everyone, hope all are doing good. So welcome to DevOps Motivation YouTube channel. And in today's topic, we'll see about Kubernetes interview questions part 2. So in this part 2, we'll be seeing about cluster and architecture. If you have missed part 1, I'll attach that particular video in our description. Please check it out. And without further delay, let's jump straight into the interview questions. So the first question would be, what is a Kubernetes cluster? A Kubernetes cluster is a set of node machines for running containerized applications. So if you are running a Kubernetes, you are running a cluster. At a minimum, a cluster contains worker node and a master node. So if you see the diagram, we have the Kubernetes master node and we have three different worker nodes all connected via networking. So this constitutes a Kubernetes cluster. Moving on to the next question, what is a node? A node is a virtual or physical machine that serves as a worker for running the applications. So it is recommended to have at least 3 nodes in a production environment. So in this particular diagram, you can see there are multiple nodes, that is node 1 and node 2. And this is nothing but a bare metal server, or it can be a virtual machine, which is the case often. So in AWS terminology, this is nothing but an EC2 machine. So that is on the node side. What is master node is responsible for? So master node, it is an important node in Kubernetes, and it coordinates all the workflows in the cluster. So it is scheduling the application, it is managing the desired state of the cluster, and it will be also useful for rolling out new updates. Next question would be, describe shortly and in high level what happens when you run kubectl get nodes. It can be either kubectl or kubectl, whichever is your pronunciation preference. And so once you initiate that command, the first would be your user will be getting authenticated, and kube API server. So that's the component which will try to validate the request. And once the request is validated, the data will be retrieved from etcd server. Next is a true or false type. Every cluster must have 0 or more master nodes at least one worker node. So the answer is false, because a Kubernetes cluster should have at least one master node. So master node is mandatory and it should be at least one in count, and it can have 0 workers. Although that is not useful because we need to have a worker node to run our application. Next question would be, what are the components of the master node, also known as control plane? So master node, also known as control plane, it can be used interchangeably. So both means the same. And the components are API server, which is the Kubernetes API, and all the controller cluster components will communicate via API server. And we have the scheduler, which is used for assigning the application with the worker node it can run on. And we have the controller manager, which is used for doing the cluster maintenance, like setting the required number of replications. And in case of node failure, all these activities are done by controller manager. And we have the etcd, which will store the cluster configuration. So if we visualize it in the diagram, we can see the master node, which is having the API server, which is like this particular API server is used by all the components. You can see the incoming arrows, and it is communicating through REST API. And we have the scheduler, which will schedule the pod to the appropriate worker node. And we have the controller managers, which will be running inside a reconciliation loop, and it will see whether the cluster is in the desired state. And we have the etcd, which is acting like a database to store the cluster related information. So this is on the master node components. Next, let's go to worker node components, and we have 3 components. So first is kubelet. So that's an agent responsible for node communication with the master. And kube proxy, which is acting as a networking component, which will also like load balance the traffic between the application components. And we have the container runtime, which is the engine used to run the containers. So it can be either Podman, Docker, and etc. So if we visualize it again, so this is the control plane which we saw in the previous diagram, and it is connected to the worker node. And we have the different pods that are running, which is hosting the containers. So the pod, it can have multiple containers inside them, and all the pods will run on the container runtime. Here it is Docker, and we have kubelet as well as kubeproxy. So these are the worker node components. Now, let's get into a small quiz. Like we have the diagram and we have the control plane, which is the master node, and we have the worker node. And in the right side, we have the different components. So let me just zoom in. Yeah. So this is the control plane, this is the worker node, and we have the components. We have kubelet, API server, kubeproxy, etcd, controller manager, and scheduler. So just take few minutes. If you want to pause the video, feel free to pause it, and then try to match the components to the appropriate nodes. So yeah, I'll give a few seconds of time. You can just think through it. All right. Hope you were able to figure that out. So let's go to the answer. Okay. So in the master node, we have the API server, which is the central component for all the components to communicate via API. And we have the scheduler, HCD, and controller manager. So all these four components are in the master node. And we have the kubelet and kubeproxy in the worker node. We also have the container runtime, which will also be there in the worker node. So yeah, if you got it right, pat on the back, congratulations. Let's get into the next question, which is the component flow diagram. So we have all these components. How do they interact? Like what is the flow of this particular components? So first we have the client, which is nothing but from the kubectl commands, we'll be communicating to Kubernetes cluster. And the first component it is trying to hit is API server. So client is saying, hey, I need a pod. So create a pod. So API server will get that particular request and it will store the object definition in etcd. So object definition is nothing but details about the pod. And then it controller manager will create the pod resources and update the etcd. And the scheduler, it will identify where the pod has to be created and it will update the state in the etcd. So kubelet, which is on running on the worker node, it will retrieve the template for the pod. So it will fetch that particular pod template from etcd, and it will be serving that particular pod creation. And finally, it will be the Docker engine, which is an important component. So on top of the container runtime, the container will get created. And kubelet, once the container is created, it will update the state in the etcd, whether the uh, pod is in running state or not. So yeah, this is the flow diagram. Coming to the next question. So you are managing multiple Kubernetes clusters. How do you quickly change between the clusters using kubectl? So there can be like multiple contexts. Say, for example, you can work on dev environment, you can work on staging and production. So how to switch between them? So you can use the command kubectl config and then use context followed by the context name. So that's the command. Next question is, how do you prevent high memory usage in your Kubernetes cluster and possibly issues like memory leak and out of memory issue, which is OOM? So there is a concept called resource limit. So we need to apply the request and limits. So If you are uncertain, like if the application is there, you need to do the capacity planning, and then you need to apply the resource limits, which is request and limits. Coming to the next question. So in case if you face an question like, do you have an experience with deploying a Kubernetes cluster? If so, can you describe the process in high level? So you need to start something with, for creating multiple instances, you'll be requiring Kubernetes nodes or workers. So you'll be creating them. And also you need to create the master node. So once they are provisioned in a cloud, say for example, AWS or Azure or GCP, so you need to have virtual machines to have it. If you are like creating the cluster by yourself, you can create the virtual machines. Or there is also another option, like if you are having, if you are planning to use a managed resource, you can do it via AWS EKS or Azure AKS. So those are like managed services which can be done. So once that is done, so here we'll be looking into how you'll be setting it up instead of relying on the managed service. So you'll be creating the virtual machines, so it can be termed as master and worker nodes. So once that is done, you'll be provisioning certificate authority that will be used to generate the TLS certificate for different components. So certificates are required to secure the communications between the components. So once that is done, like certificate authority is done, you need to certificate, like generate the certificate and private key for the different components. And another important step would be generated the kube configs, so that different clients of Kubernetes can locate the API server. So you need to have the kube config, which is useful to communicate with the server. So for the client server communication, kube config is a must. And then generate the encryption key that will be used for encrypting the cluster data. And then you can create an HCD cluster, which will store all the cluster related configurations. So these are the high level steps that you can use to say like you have deployed a Kubernetes cluster. Next would be which command will list all the object types in a cluster. So kubectl API resources will list down all the object types. Next question, what is like kubectl get component status do? So it will output the status of each of the control plane components. So we saw the control plane components. It will state like whether it is in running state or not. Create list of nodes in JSON format and store it in a file called some nodes.json. So if that is the question, we have kubectl get nodes and then -o flag for output, which should be in JSON, and we can write this particular output into some nodes.json so that we can see the output in a JSON format. So that is for the part 2. We just saw about cluster and architecture and the relevant questions. If you like my content, make sure you hit on that subscribe button so that you will be notified on the future interview parts. So we'll be having multiple parts in the Kubernetes series so that you are interview ready for it. And also there will be other topics in DevOps, which we'll be discussing in the future. So yeah, please do subscribe and hit on the notification icon. And thank you so much for your time. See you in the next video.